Okay, for today's video, we'll be talking about the surface area of cones and spheres. So we haven't covered this in class. Unlike pyramids, I had touched on pyramids last week. Cones and spheres we had not touched on. So you'll need to make sure you pay attention. I'll talk about how these formulas come about maybe at some later time. But for today, we're just going to sort of accept the formulas, learn how to use them and apply them in context of questions. So first of all, we'll deal with the surface area of cones and spheres. And we've got this formula here where the surface area is pi r squared plus pi rl. Now, the pi r squared is pretty easy to see that part's going to relate to the base of the cone. And the pi rl relates to the curved surface that fills the cone, where the r is the radius of the circle base. L, though, is the slant height distance. And you'll see here on this particular picture, in blue here I'm highlighting the H, which is the height of the actual cone, and L is that slant height, which I've highlighted in purple. So you may be given one or the other of those. Now, if you're given the L, the slant height, then you can plug it straight in the formula. But if you're given just the height of the cone, you'll have to use Pythagoras, because one thing that isn't stated there is that this situation will create a right angle, even an ugly right angle like that one. How about we do one that's a little bit nicer than that? Well, not much better. Okay, so in this particular instance, we'll start with a very basic one. Here we've got the slant height provided, and we know the diameter, so we know that obviously the radius is half the diameter. So we can just use that formula. Surface area equals pi r squared plus pi rl. And I do want you to get in the habit of writing the formula, substituting, and then evaluating. So obviously here we've got pi times the radius. In this particular case is going to be 8 because 16 is the diameter. And then it's pi times the radius times the slant height, or the slant side of that cone. Now, I think you should be pretty comfortable with the idea that 8 squared is 64, and 64 lots of pi. We can deal with pi, to save using the calculator, we can deal with pi like it's a bit of algebra, at least for a little while. And if we look at this side, 8 times by 12, well, that's going to be 96. If you're not good with these sorts of things, it's not a bad idea to practice your times tables, and this is a great way to do that. Now, 64 plus 96, well, if I add 4 onto 96, I'm going to get 100. So that's going to be 160 lots of pi, which I can put into my calculator. Now, I could have put that all into my calculator early, but as I was saying the other day, we need to start getting comfortable with the idea that sometimes we want to give our answer in exact form. So 160 pi is the answer, obviously surface area, so I've got to give it in units squared. But 160 pi is an exact answer. Once I put this in the calculator and press equals, what I'm left with there is an approximation. A fairly accurate approximation, but still an approximation. So I'm going to say a 502.7. And we're in centimetres, so centimetres squared to one decimal place. Important to remember that when we're talking about surface area, we're thinking about wrapping the object. So think about Christmas time. We've got the object and we're wrapping it in Christmas paper. Although it's a three-dimensional object, where with surface area we're concerned with exactly sort of how much wrapping paper we'd need to cover that particular object. So here in example 2 is an example much like I suggested we might have. If we assume we draw the radius on like so, in this particular case we actually do know the slant height and we do know the actual height of the object. What we don't know is that radius of that circle, but as you can see, a triangle there sort of gets created, a right angle triangle, and we can use that to work out that radius. So we're going to start first with that idea of applying Pythagoras to find out the last bit of information. So in this particular case, c squared is 40 squared and b is going to be 32, so it's going to be 32 squared. This one I will put in the calculator because I don't really know my 40 squareds that well. Well, actually 40 squared wouldn't be too hard, but 32 is a little bit harder. 32 squared, and we end up with 576. So a is the square root of 576. And for that, I might just pop that in the calculator as well. So I can press the square root of answer, and that'll give me 24. So there we are, our radius is 24. So now we've got all the details we need to use that formula. So the surface area is pi r squared, just the area of the base, plus pi rl, as given in that formula up there. Okay, so we know what pi is. R is 24, so 24 squared plus pi times 24 times the slant height. Make sure you use the right one, and that in this case is 40. So if this time I'll probably just plug that in on my calculator. I'm going to go shift pi. Obviously didn't see the shift sign. There we go, shift pi times 24 squared plus pi times by 24 times by 40. And that's going to give us, we'll go to 4825.5. And our units are millimeters, so that's going to be in millimeters squared. Okay, this next question's asked us for the exact surface area. And what exact means is we are not going to use the calculator. We're going to give an answer in terms of pi. So luckily enough though, every bit of information I needed is given. So the surface area is pi r squared plus pi rl. So if we work that out, the radius is 5. So it's going to be pi times by 5 squared plus pi times by 5 times by the slant height, which is 11. Well, 5 squared is 25, so we're going to have 25 pi plus 5 11s are 55, so that's going to be 55 pi. We can deal with pi like it's x or y or something like that, like we're doing algebra. So in this case, just like if we had 25x plus 55x, we can do 25 pi plus 55 pi. So when we add, we just add the numbers together if it's the same pronumerals. So 25 plus 55, that's going to be 80 pi, and that's not the end. Obviously, it's 80 pi centimeters squared, still in those units. So 80 pi is more exact than actually putting 80 times by pi in the calculator, because once we put in the calculator, we're getting an approximation. And if you're doing higher level maths where we need to take a few more steps yet, it is a lot easier to leave it as 80 pi than to have some number with a whole lot of recurring decimals. Okay, so moving on to the second half of the lesson now, which is into spheres. Spheres, we've got once again a simple formula to use, and in this one the only thing we need to know is the radius. So a sphere is just, I guess a ball is a sphere, but it's defined by a, I guess you could think of a circle that's rotated 180 degrees through one of its diameters, or it's also, if you imagine a point in space, a sphere represents an equal distance away from that point in space in every direction. But yeah, the easiest way probably to think about it is as a ball. So the surface area is just 4 times by the area of a circle that would fit in the center. So nice and simple. It just changes a little bit when we're doing hemispheres, or which is a hemisphere is a half of a sphere. So we'll just do this first example here where we just need to substitute in. So it's 4 times by, well actually I'll write the formula. Surface area is 4 pi r squared. And obviously pi is a number just like 4 is a number. So the only actual thing we need to know to work this out is the radius, and that's given us there as 12 squared. So we can plug that all into our calculator, and we're going to have 4 times by pi times by 12 squared. And that's going to be 1809.6. And we're in centimeters, so that'll be centimeters squared. Calculate a diameter of a sphere that has a surface area of 600 centimeters squared. So if we think about that surface area formula, it's 4 pi r squared. We don't actually know what the radius is in this case, but we do know that the area, the surface area, is 600. So we can replace that, and we're left with 4 pi r squared. So obviously now, if we think about it, we can use a bit of algebra here. If we divide both sides by 4 pi, that's going to get rid of everything on this side that's not related heavily to r. So we're going to be left with 600 over 4 pi equals r squared. And then if we take the square root of both sides, we're going to end up with r equals the square root of 600 over 4 pi. And we can bang that into our calculator. So we need to do the square root sign first, and then put a fraction under the square root. So 600 up the top, and down below we'll have 4 times by pi. And that's going to give me we'll go with 6.9 in this particular case. Centimeters. Now, is that the end of the question? I don't think it is, because the question asks us what the diameter is, not the radius. So we're going to have to finish off with, therefore, diameter equals 6.9 times by 2, which is going to be 13.8 centimeters. The exact surface area of the sphere shown. This is another good example of using the exact form of pi rather than putting in the calculator. So the surface area is that same formula, 4 lots of pi r squared. And in this particular case, we know that 4 and pi are just numbers, but the radius is 10, so that's going to be 10 squared. So that's going to be 4 times pi times 100. 10 times 10 is 100. 4 times 100, well, that's 400. And then we can just write it like algebra, 400 pi. But we still need our units, meters squared. So 400 pi meters squared. Now, we've got a few other examples here. I'm going to leave the Earth question. I would like you guys to all have a crack at that and see what you can get as an answer. So that's example 8. I want you guys to do that before you have a go at the questions in the book. But first, I'll quickly do a hemisphere because one slight change. So a hemisphere, if the surface area of a closed sphere is 4 pi r squared, then a hemisphere, it depends on whether or not it's closed or open. So closed, we're going to have half the sphere, so that's 2 pi r squared to take up half the sphere. But then because we've halved it, we've also got this circle here. I'll just use my highlighter. This circle here is now included. So we've got one of the circles. So I'll just write here, that's for a full sphere. So for a closed sphere, the surface area is actually going to be 3 pi r squared. So half of the normal surface area would give us 2 pi r squared, plus now we've got this circular disc on top. So we substitute into that formula. We have 3 times pi times our radius, which is 15.4, and we square that, and we'll plug that all in the calculator. So 3 times pi times 15.4 squared, and that comes out as 2235.2 centimeters squared to 1 decimal place. Okay, so just remember that an open sphere, and I won't do this actually that's a hemisphere. I'll rewrite that. And a closed hemisphere, sorry, that's a closed hemisphere, an open hemisphere, if it was more like a bowl, for instance, would have been the surface area equals 2 pi r squared, half of the original sphere. So you do have to pay attention when you're being asked about a hemisphere. You're either going to have a closed one, which is going to be 3 lots of that area of the circle formula, or you're going to have an open one, more like a bowl, and that's going to be 2 lots of that area of the circle formula. So as I said, have a go of the Earth one here. It's not too hard. There's a bit of percentages in that sort of in percentages, ratios, and fractions. There's a bit of a refresher there. I'll go through the answers with you later on and do the questions for the lesson.